A warm welcome to one and all viewing this presentation. I am JS Bhavesh Kumar here before you all to present on the topic multiplexers. So first let us look into what is a multiplexer. A multiplexer is a combinational logic component that has several inputs and only one output. So a multiplexer is also called as MUX, MUX. MUX directs one of the inputs to its output line by using a special thing which is called control bit word or a selection line to select its lines. So the main components of a multiplexer include 2 power n data inputs, n selection inputs at the same time as single output. So based on the value of n, we can classify a variety of multiplexers. Selection input determines the input that should be connected to the output. The multiplexer sometimes it is called as a data selector because we are selecting only one output from many inputs using n selection lines. So the multiplexer acts like an electronic switch that selects one from different inputs using a selection line. So it may also have an enable input to control the operation of the entire unit. Now why is a multiplexer called as a data selector? Let us look into the reason. So as I said earlier, multiplexer is a combinational logic circuit with more than one input line. So it accepts the binary information from several inputs or sources, and depending on the selection lines, property of selection lines, so it determines which input to be given as output, thereby only a particular input line is routed onto a single output line. This is why a multiplexer is called as a data selector. Now, the basic idea of multiplexing is shown in the above figure, in which the data from several sources, so let it be source 1, source 2 and source 3, they are routed to a single output line when the enable switch is on. So when the enable switch is off, this operation is not performed. This is why multiplexer are also called as many to one combinational circuits, because they are sorting out from many inputs to a single output. So using the help of a switch or a selection line. So the basic understanding of multiplexer along with its pictorial diagram has been depicted in the picture. So where the input signals, let it be n, at the same time let m selection lines be present in the multiplexer with only one output signal. So we know that based on the value of m, so we can say that n is equal to 2 power m as per the principle of multiplexer. So this diagram illustrates the basic idea of multiplexer. This type of multiplexing is generally referred to as 2 power n cross 1 multiplexer or 2 power n to 1 multiplexer. For example, if the number of input lines is 4, then we know that input line should be expressed in the terms of 2 power n. So 4 can be expressed as 2 power 2. So here 2 represents the number of select lines. At the same time, 2 power 2 represents the number of input signals. So the input signals is 4 and 2 select lines are required for building a 2 cross 1 multiplexer. Similarly, to select one of the 8 input lines, 3 select lines are required. Generally, the number of data inputs to a multiplexer is a power of 2, such as 2, 4, 6, 2, 4, sorry, 2, 4, 8, 16, and many numbers in 2 power n. Some of the most frequently used multiplexers include 2 to 1, 4 to 1, 8 to 1, 16 to 1. So these are the major applications of multiplexers. At the same time, multiplexers are also available in many IC form, integrated circuit, so with different input and select line configurations. Some of the available multiplexer ICs include the following one. So for 2 to 1 multiplexer, we have the following two types of ICs, and 4 to 1 74153 IC. At the same time, the following ICs for 8 cross 1 and 16 cross 1 multiplexers. Now let us look deeply about what is a 2 cross 1 multiplexer. 2 cross 1 multiplexer, there are only two inputs. So a 2 represents number of inputs, cross 1. 1 represents the output which is produced, that is single output. So it generally means that uh, 2 cross 1, which means only one selection line is used, that is S0. So on the single output is determined based on this selection line. So on the basis of combination of inputs which are present on the selection line S0, one of these two inputs will be connected to the output. So the block diagram along with the truth table of the 2 cross 1 multiplexer is shown below. So here A1 and A0 represents the two inputs. At the same time, only one selection line is used because 2 power 1 is 2. So 2 represents number of inputs and 1 represents power represents the number of select lines. So number of select lines is 1. Based on the select line, output Y is produced. So this is the basic truth table diagram. At the same time, the logic expression, so for the output Y is as follows. Now looking into the logical circuit for 2 cross 1 multiplexer, it can be constructed using two AND gates and one NOT gate at the same time with an OR gate at last for combining two different cases. So this is the basic logic circuit diagram for 2 cross 1 multiplexer. Hope that 2 cross 1 multiplexer concept is clear. Now let us look into a 4 cross 1 multiplexer. 4 cross 1 multiplexer also has the same principle, but here the number of inputs is 4. So because we are taking 4 inputs, so it will be 2 power 2. So representation. At the same time, the power 2 represents the number of select lines. Let it be S1 and S0, and the input lines be A0, A1, A2 and A3. Now we know that the basis of multiplexer is only one output is produced, let it be Y. So this is the general block diagram of a 4 cross 1 multiplexer. At the same time, the truth table for the 4 cross 1 multiplexer is depicted as follows. The logic expression of the term Y is as follows. So from this logic expression, it is evident that the logic gates can be connected as of the following logic circuit diagram. So where only two NOT gates are used, at the same time 4 AND gates and an OR gate is used to depict the entire 4 cross 1 multiplexer. Now let us look into the third basic multiplexer, 8 cross 1 multiplexers. So 8 cross 1 multiplexer, so as the name suggests, it has 8 inputs, 3 select lines, because 8 inputs can be represented as 2 power 3, where 3 represent number of select line, only one output. The basic truth table diagram is being given along with the logic expression, and logic circuit of the above expression is given below. So hope that the concepts of 2 cross 1, 4 cross 1, 8 cross 1 multiplexer is clear. So the main important thing which we need to notice the use of enable in 8 cross 1 multiplexers. And at the same time, block diagrams give a pictorial representation of how a multiplexer can be represented, and truth table will mention the number of possible inputs and the values of corresponding selection lines for the particular output. So this can be represented in form of truth table, and logic expression can be derived from it. So at the same time, it is can be logic circuit can easily be generated with the help of logic expression from the truth tables. So now let us look into the derivation of an 8 cross 1 multiplexer using a 4 cross 1 as well as 2 cross 1 multiplexers. So for deriving an 8 cross 1 multiplexer using 4 cross 1 and 2 cross 1 multiplexers, we need two 4 cross 1 multiplexers, because in an 8 cross 1 multiplexer we have totally 8 inputs. So by using 4 cross 1 multiplexers, we can divide those 8 inputs into 4 and 4, two 4 cross 1 multiplexers as shown below. So this is the diagram. At the same time, we know that for a 4 cross 1 multiplexer, only two select lines are required. So this is being depicted in the diagram. Now the outputs. So generally a multiplexer has only one output. So each 4 cross 1 multiplexer gives one output. So there are a total of two outputs because we use two 4 cross 1 multiplexers. So these two outputs can be given as an input to 2 cross 1 multiplexer with only one select line. So the final output produced from this 2 cross 1 multiplexer represents the entire working of an 8 cross 1 multiplexer. So I hope that the pictorial diagram representation of 8 cross 1 multiplexer in terms of 4 cross 1 and 2 cross 1 multiplexer is clear. Now let us look into the derivation and simplification of a complex multiplexer, means higher order multiplexer, from 8 cross 1 and 2 cross 1 multiplexers. So that is nothing but 16 cross 1 multiplexer. So as said earlier, a 16 cross 1 multiplexer, its inputs can be divided into two parts, 8 and 8. So we can represent it in form of 8 cross 1 multiplexer, and the corresponding outputs can be connected to 2 cross 1 multiplexer to produce the final output. So also that we can also have 4 cross 1 multiplexers, and connecting the outputs of 4 cross 1 multiplexer to a single 4 cross 1 multiplexer to produce an output will give you the same answer as that of the output which is produced from 16 cross 1 multiplexer. So Higher order multiplexers can be easily simplified and represented by using common multiplexers in the order of 2, 4 and 8, so that the diagrams looks easy to understand and its complexity can be easily reduced. So far we have seen the types of multiplexers and what is a multiplexer and what are the three main components of multiplexers. So let us dive back into main points related to multiplexer, nothing but look into the real world applications of multiplexers. So the following four are the real world applications of a multiplexer. So first thing is it is generally used in telecommunication industries. So they combine multiple telephone signals into one for transmission over a single line and enhance the efficiency of communication system. So multiplexers generally produce an output of one. So from many input lines. So the inputs can be taken as different telephone signals in this field. At the same time, the output can be taken as a single line, okay, which can be transmitted, enhancing the efficiency in communication systems. So this is the major application of multiplexers in telecommunication industries. And the second application is television broadcasting. So in cable TV systems, multiplexers combine multiple channels into a single transmission signal, allowing a variety of channels to be sent over one cable. So it has also the same principle, but here cables are being connected. So multiplexers combine multiple channels into a single transmission channel, which is a basic principle of multiplexer, allowing many channels to be sent over only one cable, which acts as the output line. So its application in computer networks is shown as follows. So it helps combine data from multiple network nodes onto a single communication channel, optimizing the bandwidth usage and improving the network performance. So the major application in real life of multiplexers is digital signal processing. So in digital audio and video processing, multiplexers route different data streams to appropriate processes or memory units, ensuring efficient data handling is being taken place. I hope that the major applications, so in fields of telecommunication, television broadcasting, computer networks, data signal processing of multiplexers is clear from the displayed picture. So now let us look into the main advantages and disadvantages of multiplexers. First thing is in advantages side, efficient use of resources. So main principle of multiplexer is to convert many inputs, multiple inputs into single transmission medium so that we can access everything from the single output. So efficient use of resources is main advantage of multiplexers. At the same time, the disadvantage is complexity in implementation. Setting up and configuring multiplexers can be complex and requires careful planning and expertise. If there is fault in something, the entire multiplexer fails. So it's complex when with the increase in order of multiplexer, its complexity also increases. So which we have to keep in mind before implementation. The next major advantage of multiplexers is its cost effectiveness. By reducing the number of communication lines needed, multiplexers can lower the infrastructure and operational cost. At the same time, we know that ICs, integrated circuits, are smaller, cheap and faster. So these multiplexers, they can be incorporated into several ICs. So as we have seen in previous slides. So by incorporating this, we can easily implement this multiplexer logic using the corresponding ICs because ICs are very cheaper, way cheaper. So we can say that multiplexers are generally cost effective because they can be implemented in form of ICs. At the same time, uh, they reduce the number of communication needed and only allow the desired output. So because of which it's effective. At the same time, disadvantage is its potential for data loss. So if multiplexer is not properly designed or it's not properly managed, it can cause data loss or single signal degradation, especially in noisy environments, analogous environments. It causes uh, unnecessary data to be lost if it is not properly managed. So both it is cost effective for combining more lines and giving desired output. At the same time, if it is not properly managed, it has the potential for data loss. This is the main disadvantage. Now looking into the advantages side, its simplified design. In complex systems, multiplexers simplify the design by reducing the number of wiring and connections needed. So looking into the disadvantage, latency. The process of combining and separating signals can introduce delays. So because if we represent a higher order multiplexer in terms of smaller multiplexers, we need to construct them separately and connect them. So this requires some time conception. So we can say that it can introduce delays affecting real-time communications if complex multiplexers are implemented. Now looking into the fourth advantage of multiplexers. So it's flexibility. So as said earlier, it can handle different types of data, whether it's digital or analog, making them versatile in various applications. Disadvantage is it's limited by capacity. Multiplexers have a maximum capacity for the number of signals they can handle, which can limit scalability at the same time require additional devices for larger systems. I hope that the disadvantages and advantages of multiplexers is clear from the displayed slide. So thank you for one and all who are viewing this presentation by GS Bhavesh Kumar. I once again thank you all for viewing this presentation.